Let's finally integrate an exponential decay. We talked about that at the very beginning of chapter 6.1. Exponential decays are important in applied probability and all kinds of other places. So the first thing I would do is graph this. Has a height of 1 at x equals 0, and it does something like that. Never quite hits 0. And what would we say? How about a quick lower bound? Do you agree this thing, the total integral should be positive, so a lower bound of 0. A better lower bound would be a height of whatever this height is. So e to the negative 4 times 4 minus 0, which again is pretty darn near 0. Upper bound would be a height of 1 and a width of 4 minus 0, so an upper bound of 4. And then a guess, you could say the guess is halfway between the upper and lower bound, so like that. And that looks like we're including a lot more in the guess than we're missing in this little triangle-ish area. Or another way to think of the guess is rotated to be the diagonal of the box, which also makes it clear that the guess is much bigger than the actual area. So it'd be basically 0 plus 4 over 2, and the guess is bigger than the actual. So let's actually go do it, and there's an interesting twist coming up. So go ahead and do U substitution with a little table and everything. Pause the video while you do that, and then come back when you've either finished it or hit the interesting little twist. All right, welcome back. So you said probably u equals negative x, du equals negative 1 dx, or negative du equals dx. So then let's do our table that's translating x values to u values. So x goes from 0 to 4, u equals negative x. Plug in 0 for x, you get negative 0 or just 0. Plug in 4 for x, you get negative 4. And so now we're going to write the integral from u equals the starting point to u equals the ending point. And at this point, lots of people probably said, wait a minute, it looks like I'm integrating backwards. Should I flip the start and stop so I integrate from negative 4 to 0? Or this is a system, should I just go with the system and hopefully it'll all work out? So we'll say here it looks like we're integrating backwards. So I'm going to not flip it. I'm just going to go with the same system I've been using and see what happens. And then we'll go back and think about, well, what if I had flipped it? So we've got u equals 0 to negative 4. We should have e to the u times, replace dx with negative du. Integral of e to the u is e to the u. Move the negative out here from u equals 0 to u equals 4. And so we get negative e to the 4, e to the negative 4, right? Negative 4 minus e to the 0 minus, so e to the negative 4 is 0.018-ish, minus e to the 0, which is 1. And then what's 0.018-ish minus 1? It's negative 0.982-ish. And then overall, this negative cancels that negative, so I get positive 0.982-ish. And how does that work with my lower bound? My lower bound was 0, and this is above 0, so that's good. Is it below my upper bound of 4? Yes, it is. And how does it compare to my guess? Well, it's kind of in the same neighborhood as the guess, and we knew the guess was going to be bigger than the actual answer. So we'll say it's reasonably close to the guess. So here, I just stuck with the system, and I didn't flip the integral so it looked like we weren't integrating backwards, and I ended up with a positive, which is what I needed. What if I had flipped the integral so it looked like we were not integrating backwards? So if we went integral equals -4 to u equals 0 of e to the u times negative du, let's try that again. There it looks like I'm not integrating backwards, which is true, but this negative here ends up giving me a negative answer. So the answer ends up negative when we knew that this answer should end up positive. So the answer, the thing to do is apparently stick with the system, even though it looks like we're integrating backwards, because we're integrating something backwards that's also negative compared to what it once was. So we'll say it looks like we're integrating backwards. Leave it that way. Don't flip it around. All right, so interesting things happening with exponential decay.